Yes. Intercepts, parabolas, asymptotes, all that good stuff. So let's find our asymptotes. X squared is equal to 0. So that's pretty much x is equal to 0. So you have a vertical asymptote at 0. X is equal to 0, which is also called what? The y what? Y-axis. Okay, so there's one thing. No coffee, please. And then we have x over x squared. The degree of the top is less than the degree of the bottom. So that means that the horizontal asymptote is what? 0. Degree of the numerator is less than degree of denominator. Therefore, y horizontal asymptote is y is equal to 0. Now y'all should remember that from algebra. Remember, if the degree of the numerator is the same as the degree of the denominator, you take the coefficients of both. So if this was x minus 1 over x, then the 1 over 1 is what? 1. So y would be equal to 1. What if the degree of the numerator was higher than the degree of the denominator? What do? Long division. And you either find a horizontal asymptote or a oblique asymptote. Y'all remember doing that? Yes, no, maybe. Okay, well let's take a little detour right quick. Let's go review this, okay? To find your horizontal or oblique asymptote. 1. If the degree of the numerator, x squared over x cubed. If your degree of the numerator is less than the degree of the denominator, your horizontal asymptote is 0, which means y is equal to 0, which means it's the what? The x-axis. Okay, so that's one test. 2. If they're the same, you can have x squared plus 1 over x squared plus 3. Doesn't matter. If the degree is the same, you take the coefficient. Well, let's do this. And let's put 1 over 2. There we go. All right. So x squared plus 1 over 2x squared plus 3. The degrees are the same. So your horizontal asymptote is what? Y is equal to 1/2. Take the coefficients.
How are the degrees the same?
I'm sorry, what?
How are the degrees the same?
Degree.
Okay.
2, the exponents. Your highest exponent. If they're the same, that's called the degree. It's the highest exponent. And then the third one is x to the third plus 1 or plus x over x. And that's where the degree of the numerator is higher than the degree of the denominator. You use long division. So x cubed plus 0x squared plus 1x. Remember, with long division, you have to what? Have all place values in there. Okay, so that's why I had to add the 0x squared. How many times will x go into x cubed? X squared times x squared times x is x cubed. You subtract, that goes out. 0x comes out. 0x goes there. That's 0x squared minus that goes out. And then how many times will x go into 1x? 1 time. So our asymptote here is x squared, or x squared plus 1. Okay. I picked a crappy example, but just remember, if the if this is x squared over x or anything like that, you're going to come out with an asymptote that isn't straight. Okay? So that's your 3 tests. Y'all remember seeing that now? Yeah, 2 people out of 9 or 10. Okay. All right, let's go back. All right, so we found our vertical asymptotes. What else can we find? What are those 2 things called that crosses the y and x axis? Intercepts. You can find those. So to find your x-intercept, what do? Plug in 0 for what? 0 for y, Hubert. That's right, class. Glad y'all remember y'all's algebra. So 0 is equal to x minus 1 over x squared. All right, finish it. Multiply both sides by x squared, you get 0 is equal to x minus 1. So what's the answer? X is equal to 1. So there is our x-intercept. Go ahead and find your y-intercept. What do you get? 0, Hubert. Because actually, no, you don't, because these is going to be undefined. So you're not going to have an x-intercept because it doesn't cross right here, see? Or right here it doesn't exist. So that one doesn't exist. You're going to have one of those dashed lines. What else can we find? You can find out if it's symmetrical or not. Remember doing that? F of x is equal to f of negative x. And f of negative x is equal to negative f of x. You remember doing that? Y'all slow. All right, so let's just check it. Plug in negative x. Plug that in. All right? Negative, I'm sorry, hold on. Parentheses. Let me redo that. Okay, gotta hit it several times. Why isn't it working?
It just did it. All right.
Parentheses minus 1 over parentheses squared. Plug in a negative x. Plug in a negative x. We get, will you please stop it? Negative x minus 1 over x squared. Does that look like f of x? No, so it's not symmetrical around the y-axis. So let's check to see if it's symmetrical around the origin. So take this, that's f of negative x minus 1 over x squared. That's what we got, and we're going to see if it's equal to negative x minus 1 over x squared. Well, if you plug in negative, you get negative x plus 1. Does that look like that? So it's not symmetrical around anything. So it's not symmetrical.
Yeah.
It's not symmetrical around the y-axis because it doesn't, f of x does not equal f of negative x. So it's not symmetrical around the y-axis, and it's not symmetrical around the what? The origin. Because f of negative x does not equal negative f of x because of that plus right there. So that means it's not what? It's not symmetrical. So we put that over here. I don't know how to spell symmetrical. So. Okay, now you do your calculus. Because now you've got this information from your algebra. So do your calculus now. First and second derivative, find your increase and the decrease in values, and then find your other thing. Put this over here so I don't use that one because I don't think that's more.
Ranyan, what's wrong? Did I go too fast? Do you remember all that stuff? Okay, we just let it sink in a little bit. You don't have to have all this stuff on your desk. I don't know who put it there. Probably Walt yesterday. Oh, okay. I'll throw that away too. Wow. You giving up? You leaving? You quitting? All right. So let's go do the calculus. F of x is equal to x minus 1 over x squared. F prime of x is going to be equal to your denominator times numerator prime minus the numerator times denominator prime over denominator squared. And the highlights is what we're going to take the derivative of. And I went ahead and squared the denominator. So f prime of x is equal to x squared times 1 minus x minus 1 times 2x over x to the fourth. F prime of x is equal to x squared minus 2x squared, y'all help me out, plus 2x and that will yield x squared plus minus 2x squared is negative what? X squared plus 2x over
x to the fourth, which will give us negative x plus 2 over x to the third. Capiche? It's so nice to be able to work without having to.
Don't worry, tomorrow we'll have it work.
I don't think so. I think we got it. That goes there. No. No. Let me just erase that. Well, thanks. All right. Y'all are just amazed, aren't you?
Oh, yes.
All right, so now we can check our increasing and decreasing values by setting that equal to 0, correct? And when we do that, we get negative x squared, negative x plus 2 over x to the third is equal to 0. Negative x equals plus 2 is equal to 0. And x is equal to what? Positive 2? Y'all check my signs. So that means, say again? All right, we only got 2 sides to check, really. Of course, I'm going to click 0 because that's the easiest number to check. So when you pick 0, what do you get? And where do we plug it in? Into the derivative, right? Where is it? There. What do you get when you put 0 in? Well, you're going to get undefined. Oh, you can't use 0 because it's the vertical asymptote. So you can't use it. So you're going to have to use 1. So use 1. 1 plus 2 is negative 1 plus 2 is positive over positive. So that means what? All these are increasing, except for 0, which is a vertical asymptote. And then 3, we'll plug 3 in. Negative 3 plus 2 is what? Negative over a positive. So you got increasing and decreasing. You got increasing values and then you got decreasing values. All right, now take the second derivative and find your C word. Concavity. You're going to have to start writing darker. So that ain't going to show up. What is your major?
Construction science.
Okay, you're going to have to use log paper and graph paper because everything's done on graph paper. Well, I don't know now, but and you got to start writing darker. Get you a 0.9 mid. If somebody had a question, did somebody have a question? Where did I get something?
I just have brain focus.
Okay. So f prime of x is equal to negative x plus 2 over x to the third. Therefore, f prime double prime of x is equal to denominator times numerator prime plus or minus numerator plus denominator prime. over denominator squared. Go ahead and put that x to the 6 there. So f prime double prime of x is equal to x to the 3rd times what? -1 minus brackets negative x plus 2 times what? 3x squared. Be careful here because you got a lot of signs. Now I'm just going to clean up a little bit. This negative makes this what? Negative. So f double prime of x is equal to negative x cubed minus parentheses. I'm going to bring that 3x just over here right now because I just don't like the way that looks. It's backwards always. Over x to the 6th. Now, could you take that 3x and put it with that negative and distribute it? Yes? Because it doesn't matter where you multiply because multiplication is commutative. So I'm going to distribute that negative 3x now. So that's going to give me, trying to get it where y'all can see it. F double prime of x is equal to negative x cubed minus 3x squared times negative x is positive 3x what? Cubed. And then negative 3x squared times negative 2 is negative 6x squared over x to the 6th. Yes.
The x. No, I see it. Yeah. I'm good.
That's the greatest thing about this system is you can shrink it. Because I didn't write big, I could make it bigger. But anyway, show it. F double prime of x is equal to -1 plus 3 is 2. X to the 3rd minus 6x squared over x to the 6th. 2x squared. And what does that leave? X minus what? 6. Over x to the 6th. So our final answer for f double prime is 2 times x minus 6 over x to the 4th. Now, you could, hold on, you could just factor out x squared instead of a 2. You could rewrite that as 2x minus 12 over any of those I'll take. Now, what was your question?
You mean x minus 3 because you distributed the 2?
Oh, thank you. Yes, you're right. Yeah. And then let's check our concavity. We've got to set that equal to 0. So that's going to be 0, 2x divided by 2, 3. Concavity 3. All right, now let's check the concavity on the left, which will be, well, we can pick 1 or 2. 1 would be easier. 1 minus 3 is what? A negative. Negative times a positive is a what? Negative. Negative over a positive is negative. So concave down. And pick 4.
4 minus 3 is positive. Positive times a positive over a positive is what? So concave up. Sorry, I'm loud. Sorry. So, sketch it. I don't give a shit. Some kind of people that. All right, sketch it or match it up with your graph, either one on your calculator. I just want you to understand what you got. Because the next couple of days, we're going to talk about what you can get off the graph from all this stuff.
So when you're looking at your number line, you want left to right, and just knowing what's going on.
Well, it could be like this. That's concave down, and then concave up. It could be just a little portion of that. You have to look at your increasing and decreasing values. The increasing and decreasing values, I didn't forget what they were. It's increasing from negative infinity to 2. And then what?
It's decreasing. No, it's increasing.
Let me turn back. Hold on. Oh, did I have it there? Yeah, there it is. It's increasing from negative infinity to 2 and decreasing from negative infinity, or from 2 to positive infinity. That's what it says. So look at it. Let's pull it up. Remember, the x values are decreasing. You can't read decreasing and concave the same. You got to, let me just draw it. Well, I'm waiting. So y is equal to x minus 1. Oh shoot, I gotta put that in parentheses. Why is these L's flashing, or is that just me? Oh, they are?
They're just retarded.
Okay, that's all. Second insert.
It'll be highlighted.
Second insert. Oh, really? I suck. I know I suck. I know I suck. Just leave me alone. At least I admit it. Oh my gosh. I'm ready to quit. Divided by, y'all see how computer literate, I can't stand calculators. All right, x minus 1 over x squared. And graph. And of course, you're going to see it's decreasing. The x values are increasing. See, they're increasing. And then here, we got to turn right here, they're increasing. The x values are doing what? They're increasing. But you got concavity down here. And what do you got here? Concave up. And that's how you have to read it. But of course, zoom, standard. There it goes. Now, blow it up, zoom box, or use your window, whichever one you want to do. And just get in this middle area, right in here. When you do zoom box, you have to hit enter, not graph. See, there's the concave down, and there's the concave up.
So why are the x values decreasing after 2?
Because you see a tendency right here. You see, what is that line doing right there?
It's starting to go down.
It's getting closer to
It's
the.
decreasing.
It's to go bigger than the x-axis. Is it not?
I have to move over and see. need to check 3 again. Negative 3
Even if
plus
it's
2.
going down,
No. Yeah, negative 3 plus 2. Whoa. No. It's supposed to be positive. Negative 3 raised to the third power is what? Negative. Negative over a negative is what? Positive. So it's increasing.
it's increasing all the way down.
Mm-hmm.
Okay.
So it's increasing all the way. So that needs to be changed. I messed up. Let me pull that up if I can. Those that didn't catch that, what's negative 3? I meant 3. Sorry. Plug in 3. What's negative 3 plus 2? A negative, right? Negative 4 plus 2. Negative 5 plus 2. That's a negative. What's 3? Well, no, that's wrong. That's still right. Still negative. The function is decreasing as it approaches infinity.
No, it's right. No, it's increasing. It's a negative divided by negative.
So we got it backwards.
Negative 3 to the third power is negative
No.
7.
No, but it wouldn't be a negative x on the bottom.
Right here.
Yeah.
You raised it 3.
Negative-
It's
you put
not
it-
a-
I
Negative
wouldn't put
3,
in 3.
yeah, you put in positive 3. The bottom is going to be positive. So, and it is decreasing. If you look on the graph, right here, you see this line right here. For those that can see the board, can y'all see that line right there?
Yeah.
Is that line higher than this line?
Yes.
So what is it doing?
Starting to-
It's starting to decrease. But you got to blow it up. So let's move over there. Zoom out. Well, I gotta go over here and blow it up, blow it out a little bit. So, and then I gotta okay, there we go. And then zoom box. See it?
But isn't that along the x-axis though?
Yeah, but what is the function doing?
Decreasing.
It's decreasing.
Okay.
Remember y, you got to think about what is the only thing, what is y doing? It's decreasing.
Gotcha.
And that's what it's asking you. Okay? The function, what is it doing?
Gotcha.
All right, let's do another one. I got one already picked to confuse you. Actually, I'm going to give you an easy one first. I hope it's easy because every time I say something's easy, it turns out to be like rocket science. Problem 0. There we go. It's one of your homework problems. So I'm helping you with your homework. Dang, oh, got to use complete and square. But y'all had a pretty good teacher that reviewed complete and square, so y'all should be able to do it. That sucked at punching stuff on the calculator. I'll help you out with the y-intercept. The y-intercept is negative 40. I help y'all out so much. Yeah, exactly.
I have a question.
Mm-hmm.
It's unrelated to this, but how many absences can we have?
I've heard 2, but I don't drop anybody. The reason I don't drop anybody is because I give the videos online, and to me, if you can watch the videos, then, well, except for the last 2 days, but, I give people a little bit of leniency since I do the videos. And plus, I don't want to have to deal with the paperwork, because as soon as you drop somebody, what do? They come back. I want to be reinstated, and I have to redo the paperwork. And I refuse to do busy work.
Does Tri-County automatically drop people? Or do we have to drop?
Well, the first week of the summer, if you don't show up, the first week of summer semester, yeah. If there's 2 absences turned in on the attendance tracker, the computer automatically drops you. But I try not to drop anybody. After that, I try not to. Unless I don't like you. I'm kidding. As Rocky says, I love almost everybody. That's Rocky 5, the one that he should have never made. Movie sucked. At least you know this is a parabola, so you know what it should be doing. Now I got Rocky's thing in my head. Y'all done? All right. there's your y-intercept. X-intercept, x squared minus 6x plus blank is equal to 40 plus blank. Half 6 is 3, 3 squared is 9. X minus 3, quantity squared, is equal to 49. Now you got a vertex. So y-intercept, vertex is equal to what? 3, comma, negative 49. That matches with this because the vertex on a parabola is either higher or lower than the y-intercept. If it's not the y-intercept. And then square root x minus 3 is equal to positive or negative 7. X is equal to 7 plus 3 is 10. And negative 7 plus 3 is what? Negative 4. Huh? So there's your x-intercepts. You can check to see if it's symmetrical, but we all know it is, so you don't have to check that. Increasing and decreasing values. G prime of x is equal to 2x minus what? 6. So therefore, you've got you check it with setting it equal to 0. 6 comes over 3. So plug in 0. What do you get? You get a negative number. So on the left, it's decreasing, is it not? Put your car up on it, it's going downhill. And then, of course, we know that if you plug in 4, you're going to get what? Positives. G prime, double prime of x is equal to 2. Well, heck, what do you do there? Well, you know that it's going to be what? Positive, because 2 is positive. So it's concave what? Up. And we all know a parabola is concave up.
Yeah, on the increase and decrease, it's negative over 3 on the path 3 on the vertex, right? If you look at the 3 there.
You can look at that too. But on a parabola, you know that. That's why I showed you this, because you can actually picture a parabola and you can picture these things. But not all functions are parabolas. And not all business applications are parabolas or logs. So that's why you got to learn how to find this stuff, even though most of the time you just look at the graph, but you got to find certain things, especially inflection points. Okay? All right, so let's do a nerding. Y'all don't get too excited.
Just like that.
Let's see which one I'll pick. That one.
How many people failed that in-class test?
I don't even want to talk about it. I can't believe y'all failed such an easy test. Let's go with that one. And then we'll do this one. So write both of them down on separate sheets of paper. What I can't believe is people actually made zeros on it. I mean, the chain rule was the easiest one of all. I guess I'm just a terrible teacher. That's what it is. It's my fault. Speaking of zeros, I've actually got 3 or 4 people in the classroom that have zeros on their homework. Not just 0 sections, I'm talking about 0 for homework. You know, when you go to your grade book and it shows you,
Homework grade.
it's got 0 for homework. You know why people can't pass math? It has that 4-letter word. What is it? Lazy. That's it. I just don't understand why I can't graduate. It's that stupid calculus. I can't pass it. How much homework do you do? None. I can't pay my student loans.
Real lazy people like.
Not only is the U.S. turning into a wussy nation, we're also turning into a lazy nation. Chastising someone getting a trophy because they trained harder than the other people. Don't chastise people. Ugh. Don't want to call valedictorians valedictorians. Want to say something else. That's one of the high schools. They had a big uproar. I can't remember which one it was, but I want to say it's in Florida, where they don't want to use the word valedictorian and salutatorian or whatever it's called, salutatorian or whatever.
The valedictorian in my high school would cheat.
What?
He would cheat.
I didn't hear you.
He would cheat.
He would cheat. Like I said, lazy nation.
If he had like multiple tests in a day, he'd skip and then go and like take each test individually on separate days.
So he's that, so he could have a better chance of cheating.
Well, like he could like study for each test like the night before instead of studying for all of them.
My nephew was salutatorian at Westside one year when he graduated. He went on to the Citadel, got an appointment at West Point. He picked Citadel over West Point. I mean, he had a seat at West Point. He got appointed by Lindsey Graham and one of the other congressmen, and went. I don't know. It wasn't Tim Scott at that time. This was 5 or 6 years ago, and yeah, trying to think who it was. No, he's lower part. Sanford, he's lower part. But anyway, make a long story short, his daddy said it would be better if he went to the Citadel. You dumbass. I mean, Citadel's a good school. Citadel, West Point. No. That's who it was. It was Jim DeMint. Before he went to the Republican Conservative Heritage USA, I think it's Heritage, whatever. I can't remember what it was. But anyway, that's Tim Scott took his place, didn't he? I think.
I was the homeschool valedictorian in South Carolina. On the team.
You were?
Yeah.
Good job.
Wait, what'd you say?
You're still gonna live in the ditch.
It's okay. Yeah. I got a t-shirt and everything.
That's funny. I got a t-shirt and everything.
You were the smartest homeschool in South Carolina.
You know, if you ever thought, if you were the last person of the senior year, last ranked of the last ranked school, the last ranked state, you'd be the dumbest person in the United States. So think if you were the last ranked student at the last ranked high school, I'll pick on West Side since I went there, and that year, South Carolina was last in the state, and West Side was last in the, you'd be the dumbest person in the United States.
With the high school education.
Yeah,
Theoretically,
yeah, theoretically.
there's always people who didn't even make it.
Oh, yeah, there's always people that can't spell mom backwards, yes, I know. All right, so h of x is equal to negative x cubed plus 48x, because I can't stand this. I don't know why they do that. I can't stand it. H prime of x is equal to negative 3x squared plus 48, and h double prime of x is equal to negative 6x. Check it. Make sure. I went ahead and did the calculus because I'm showing you that that's all the calculus there is in the problem. The rest of it's algebra. So, negative x cubed plus 48x is equal to 0. Factor out a negative x or a positive x, whichever one you want to do. You're still going to get x is equal to 0. And that would give you what? X squared minus what? 48. So negative x is equal to 0, and x squared minus 48 is equal to 0. X is equal to 0, that's one x-intercept, and, or y-intercept, what am I doing? Doing the y, x-intercept. And x squared is equal to 48, which is 6.9. Okay, and I did that with the square root of 49 being 7. And let's see, what else? We know it's symmetrical because it's what kind of a function? A cubic function, so it's symmetrical around the origin, right? Looks like that because your family of graphs that you reviewed during the semester. So now we just do increasing and decreasing. So, where am I? Okay, negative 3x squared plus 48 is equal to 0. Dang old negative, dang old divide, positive x squared is equal to 16, square root of 16. Is that right? X is equal to positive negative 4. So draw your handy dandy number line. And we got a negative 4 here, and of course that's 0. I don't put it because I don't want to think that 0 is a critical point. And 4, so there's your critical points, or critical values, whatever book you're looking at. 0. Let's see what 0 gives us. 0 plus 48 gives us what? Positive. And if you think about the cubic function, it looks something like that. So increasing would be kind of in here. And it's probably going to be increasing here, so let's go ahead and check it. 5. 5 squared is what? 25 times negative 3. Is it decreasing?
Yeah, it goes decreasing, increasing, decreasing.
Okay.
It's like that.
Just like that one up there, but backwards.
Oh, duh. I'm sorry. Like that. However it's supposed to look. I'm sorry, I forgot about the negative. All right. And this side is going to be negative 5. Negative 5 squared is positive 5. Positive 5 is going to be positive.
No, it's still negative.
It's negative, positive, negative.
Because negative 3
Negative 5. Hold on. Negative 5.
is 25.
Oh, 75. Negative 75. Duh. I'm ready to quit. Negative. So if you graph it, it's going to be, yeah, it's going to be the opposite of what I got. And then this one is negative 6x is equal to what? 0. So x is equal to what? 0. So, and of course you see that it's going to transition. Your critical point is 0, so that's pretty much where it's going to transition. You plug in negative, you get a positive. You plug in positive, you get what? Negative. So that'd be negative on this side and positive on this side. So up until 0 is concave what? Up. So it would look something like this, okay? And then this side would be concave down. So I guess it looks something like that. Or no, it'd be, yeah, decreasing.
It's almost identical to the.
In other words, this goes up in the middle. Is that what it's saying?
Yeah, it's just
So
like
it
this,
goes-
backwards.
We know that the x-intercepts are what? It takes a while to sketch it, but let's go ahead and sketch it. My x-intercept is 0 and 6.9. So we got 0, and it says positive 6.9 will be out here, and negative 6.9 will be here. That's what it says. And then your y-intercept is what? 0. So that's the y-intercept. What else we got? I think that's it. Now, from at 4, so I'm going to put 4 right here. And negative 4, I'll put negative 4 and positive 4 right about there. We know from negative infinity to negative 4, it's what? It's decreasing. And then from 4 to 4, it's increasing, and it crosses at the, so I guess it's got a little bump in the middle. Something like that. Something like that is what I would suspect. And then it also has a, so I don't know what it's doing with the, I guess it's crossing, it looks like a saddle or something. I don't know. What does it look like on the graph?
Like that, except just a little bit more.
Okay. All right, we'll do this one. And I'll get another one, and that'll be it for today. And y'all, I've done 3 or 4 problems out of your homework. So, well, no, we've still got people with zeros, so I guess they'll still have a 0, even though I do problems out of the homework. There you go. Write that as 1/64 x cubed, because you can pull the constant out. Just a thought. Don't ask me questions after I assign it, because I'm off the clock. I'm only on the clock when I'm teaching. What? Yeah. I'm a state employee. The only people that has it better than me is federal employees. They don't do anything. Hurry up, you got 3 minutes. No, I'm just kidding.
You want us to just write the interval, right?
I want you to do everything. I want you to tell me all about it. I mean, even though you don't see the graph, I want you to find everything by hand. You'll be taking the derivative, first and second derivative. The only difference in this and the first 3 we've done, this one has the graph. You don't have to graph it on your graphing calculator to check it. brain hurting? You work or were you out drinking last night? I will give this section I don't know what you call it. I will give it its credit that you actually see where your math is applicable, especially your algebra and your calculus. And then the next section, you're going to see it even more, or the next next section where we talk about marginal analysis, cost, revenue, and profit. So you can write this up as one chapter of application and 4 chapters of getting ready for the application. And you can reduce you can't reduce 364, but you can reduce 664 to what, 3/32 or something like that?
Yeah.
So, at that point, I'm really not concerned because you're setting it equal to 0. You're using the antiderivative, so it doesn't really matter. I'm sorry, the derivative. So you set that equal to 0, you're going to get, well, we're going to have to, f prime 0 is equal to 3/64 x squared minus 3, and 0 is equal to 6/64 x. Of course, divide by 64, divide by the reciprocal. The
divided by the reciprocal, you're gonna get x is equal to 0. Doesn't matter what you do there. Over here, you're gonna get 3 is equal to 3/64. X squared, multiply by the reciprocal, you get 64 over 3. 3's cancel out, you get 64 is equal to x squared. X is equal to positive or negative 8. So 0 is your critical value here. So come on, please. 1, we'll pick 1, 1. What are you going to get? 1 times 64 is positive. So what does that give you? Positive. Negative is going to give you a negative, -1. So concave down, concave up. Whatever. And see, from negative infinity to what? To 0, we basically have a parabola. And from 0, have that. Now, I'm exaggerating, but that's what you can see is concave up and concave down. You see the parabolas. So that's why I did that. Okay. Now, for the increasing and decreasing, our values are positive and negative 8. And that's 0 in the middle, so let's plug in 0. What do you get? 0 gives you a 3/64 minus 3. What is that going to give you? Negative. And then 9 squared is 81. 81 times, that's going to be a pretty stout number. So that's going to be what? Positive? Yeah, and 8 starts to go up. And then -9. -9 squared, you're going to get the same thing. So, and of course your y-intercept and your x-intercepts are the same. Y-intercept is 0. X-intercept, plug in 0 for y to solve it, you're going to get 0 also. So now you understand how to do basically 4.1 through 4.3. That's why I put the new homework up. It's 4.1 through 4.3. Okay? Questions, gripes, complaints? Okay, I need to put in the roll for the other day. I'll just make everybody